children, welcome to another session of PYQ JEE Advanced. Today I am with an organic question and all the concepts are familiar to you. A clubbing of 3 to 4 concepts in this question, that's all. All the reactions you are very familiar with. This is a question which appeared in 2023 JEE Advanced paper. So let's go through the question. Consider the following reaction scheme and choose the correct option for the major products Q, R and S. Styrene, we start with styrene. What is styrene? It is 1-phenylethene or phenylethene, styrene. Is treated with diborane followed by H2O2 in alkaline medium. We know it is a method, diborane with H2O2 in alkaline medium is a method by which you do the hydration of alkene to get converted into alcohol, and if it is an unsymmetrical alkene, the product will be in accordance with, or it will look like anti-Markovnikov product, which means hydrogen will go to that carbon with less hydrogen and OH will go to that carbon with more hydrogen when a mole of water is added, and you get an alcohol in accordance with, or which looks like an anti-Markovnikov product. So that must be P. Coming to P is treated with CrO3 in acidified medium. We all are well aware that CrO3 in acid medium an oxidizing agent, and alcohols can be, or primary alcohol can be oxidized to carboxylic acid, and followed by treatment with chlorine in red phosphorus is given. We know if it is a carboxylic acid with alpha hydrogen, then chlorine in red phosphorus followed by hydrolysis will subject it to HVZ reaction, Hell-Volhard-Zelensky reaction, where the alpha hydrogen will be substituted by halogen. You get alpha halo carboxylic acid will be the product form. Q must be an alpha halo acid. Parallelly, P is treated with thionyl chloride. We know P is an alcohol, and when you treat an alcohol or a carboxylic acid with thionyl chloride, OH is substituted by Cl or Cl minus, you can say, nucleophilic substitution, so that you will get an alkyl halide, which on treatment with sodium cyanide, nucleophilic substitution of halide by cyanide, you can upgrade. You get a product with one more carbon. Upgradation has happened, followed by hydrolysis and heating, or heating hydrolysis is done, so that you get a product R. And finally, this product R is treated with concentrated sulfuric acid, giving S. You are asked to identify Q, R and S. Let us go through these reactions now. We start with styrene. Styrene is C6H5 CH double bond CH2, and this is subjected to hydration, addition of water across the double bond, first diborane followed by H2O2 in alkaline medium. You get an alcohol which is just opposite of Markovnikov's, and you get here CH2, CH2OH, and this compound is P, which is 2-phenylethanol. 2-phenylethanol is P, and this P is subjected to CrO3 in an acid medium. CrO3 with sulfuric acid. We know that primary alcohol is oxidized to a carboxylic acid with the same number of carbon atoms, COOH. CH2COOH. CH2COOH. You get CH2COH here. CH2, a carboxylic acid with same number of carbon atom. And this compound is subjected to treatment with chlorine in red phosphorus followed by hydrolysis. It undergoes the reaction called HVZ reaction, and since it has alpha hydrogen, alpha halogenation occurs. So alpha position Cl substitutes H and you get alpha halogenated acid, and this is Q. So we have P here, we have Q here. Q is alpha halo carboxylic acid is Q. Coming to, again this P is treated with thionyl chloride, SOCl2. OH is substituted by, OH minus substituted by Cl minus, nucleophilic substitution, and alcohol gets converted into an alkyl halide. You get an alkyl chloride here. And this is followed by treatment with NaCN, sodium cyanide. Nucleophilic substitution of chloride by cyanide, and you can upgrade now. You end up with a nitrile, a cyano compound, where the total number of carbon atoms is 1 greater than the previous compound. And you have got a cyano compound, and now this is subjected to heating with acid catalyzed hydrolysis. This is subjected to acid catalyzed hydrolysis so that you get cyanides are hydrolyzed to carboxylic acid. Cyanides are hydrolyzed to carboxylic acid. Now you get a carboxylic acid which is R. This compound is R. Now it says R is treated with concentrated sulfuric acid. So when R is treated with concentrated sulfuric acid, you get when R is treated with concentrated sulfuric acid, you get concentrated H2SO4. So what happens here? Carboxylic acids, O gets protonated, acid protonates this, and once this is protonated, it enhances the electrophilicity of this carbon, because carbon, as it was quite electronegative because it is bonded to an oxygen. Now it is adjacent to, or it is bonded to an oxygen carrying positive, which enhances the electrophilicity of this carbon. So it is very good site for it can act as an electrophile and a very good site for nucleophilic attack, or you can say this acts as an electrophile and do electrophilic aromatic substitution on the benzene ring. At ortho position, para is also possible, but ortho position you get a more stable product. So at ortho position, it undergoes electrophilic aromatic substitution reaction. So naturally shift of pi electrons from this to oxygen, and once it goes to this, the shift of this electron back to this and leaving group OH minus moves. So H plus leaves from here, OH minus leaves from here, a mole of water is eliminated, dehydration as well as cyclization. So when this pair of electron moves over here, and when this H plus leaves out, this pair of electron comes back. So C double bond O is regenerated there. It remains there, and OH minus moves out. One H plus and one OH minus, dehydration resulting in cyclization. You get a cyclic product here where let us count how many membered cycle is formed. 1, 2, 3, 4, 5. 5 membered ring. So let us put a 5 membered ring adjacent to it. Now this carbon is attached to the carbon on which double bond O is present. So this carbon attached to the carbon on which double bond O is present. So this should be the final product S. So we are asked to identify the products Q, R and S. Q is this one, R is this one and S is this one. So to begin with, styrene, it underwent hydration with, we call it hydroboration oxidation reaction. You get an alcohol as in accordance with anti-Markovnikov's, which underwent, being a primary alcohol, it underwent oxidation with acidified CrO3, giving a carboxylic acid with same number of carbon atom. And this carboxylic acid with chlorine in red phosphorus underwent HVZ reaction, alpha halocarboxylic acid, which is Q. Parallelly, P is treated with thionyl chloride. OH minus is substituted by Cl minus, nucleophilic substitution reaction, followed by NaCN, Cl minus substituted by Cn minus, again a nucleophilic substitution reaction. You end up in upgrading the substance. You get one more carbon, then you subject it to H3O plus, acid catalyzed hydrolysis. So in acid catalyzed hydrolysis, cyanide is hydrolyzed to carboxylic acid. So your R is a carboxylic acid, or you can call it 3-phenyl propanoic acid is formed, which is R, which is treated with concentrated sulfuric acid, which first protonates the oxygen. Oxygen being quite nucleophilic, it can get protonated, followed by electrophilic aromatic substitution on the ring, leading to a dehydration followed by cyclization, and your S is this product. So coming to the options, if you see option B, Q is this product, and then R, you get this one, and S is this. So your right answer is option B. Thank you, children.